So these are the oval leaf buckwheat, and they tend to grow in little mounds to help retain moisture, and they have revolute, tiny small leaves to help increase the ability to photosynthesize.
You can also see that a lot of the plants grow with moss right next to them, and moss retains a lot of moisture, so this could be a climate adaptation. Something that we noticed is that the plant tends to grow in groups, so not only in groups with itself, but also in groups with other plants like the Indian's dream. Okay, this plant right here is the Murs Evesia, and we think that it's less adapted to the climate because of its color and its structure. In terms of color, it's a lot more green and it's a lot less pale like the other ones that are more resistant to the harsh sunlight. And then in terms of structure, when it's windy, this plant moves around a lot, and it's not as brittle as the other plants that we've been looking at. So we think that the wind and harsh weather conditions would affect this plant a lot more, therefore it is less adapted to the climate.
This is another example of the Alpine Fellfield plant. This is the dwarf sagebrush, and we can also see rounded revolute leaves. We think they're also similar in colors, so it can absorb more sunlight, so it has more energy to grow. This is another example of the Australasia plant. This is mountain totora, and you can see also it like stays low to the ground, and it has root as well. This is like height, maybe like 30 centimeters. If you look at the leaves, they have tiny leaves, but like really big, really thick, the branches, and I think that helps it to avoid wind, to resist wind. And also similar to Alpine Fellfield, they also have rocks with moss on them, so I think that helps with retaining the water.
Okay, this is Veronica familioides, and we think that this plant is pretty well adapted. And some examples of this, some features, are the branches that are sort of root-like, and along with that, also the fact that the plant doesn't really get above 8 to 10 inches off the ground, so it seems a lot more resistant to the wind because of the thicker branches and because of its height.
This is another example of the plant. This is Blue Mountain Biddy, and as you can see, they're very low to the ground, maybe like 2 or 3 centimeters up top at most, and it has leathery leaves and a lot of ridges on the leaf. This is probably to retain water and moisture. Yeah.
According to Miller and Rundle in Alpine ecosystems, Alpine fellfields are sloped environments with rocky soils that are characterized by their high altitudes, extreme cold, strong winds, high UV radiation, and their short growing season. They're commonly found in California, in the Sierra Nevadas, and in Australasia, in New Zealand. Plants can adapt to their environment and climate over generations and seasonally as stimuli change each year. According to Blackwell, the ability of plants to adapt to their environment is called plasticity. Plants can change their leaf size, shape, and color over time, as we observed in our ecosystem's plants, and they can also change their spread, height, and clustering.